Dear students, question number 5. Today we're going to finish with question number 5 and 6, then we will move on. So in question number 5, as usual, we have to find the displacement, average velocity, body speed, acceleration, and then we will see whether the body is going to change the direction or not in the C part. So according to the first part, as it is said by the questionnaire, all right, so they said find the displacement of the body if the displacement function is 25 out of t square minus 5t, 5 over t. So this is our displacement function, and this is the time interval in which the displacement happened. So how can you find the change in the distance or displacement? Displacement equals to displacement at the end point minus final end point minus the displacement at the initial end point, which is 1 here. So let's substitute the displacement when t equals to 5. So it's going to be 25 out of t square, which is 5 square, minus 5 over dt means 5, bracket closed, minus, then we will substitute t with 1 in the function, as at the initial point is 1 for the time interval. So 25 out of t square, which is 1 square actually, minus 5 over t, which is 1 here. So now let's simplify it further. So we get like 25 as a common LCM. So this is 25 here. If you want to make it 25, then we have to times it with 5 here and here as well. So if 5 is the common LCM, 25, then it's going to be 25 here, minus 25 here as well, minus 1 is the common LCM, so 25 minus 5. So finally we get 25 minus 25 is 0 out of 25, minus 20 over 1, which equals to, ultimately this will become 0, and minus 20 meter is the final displacement. All right, after displacement we have to find the average velocity. As we can see here, the average velocity. For average velocity, it is denoted as v average velocity, and average velocity equals to the change in the displacement over change in the time interval. Change in the displacement is minus 20. We just solve here. That's minus 20. The change in the interval is 1 to 5, so it is going to be 5 minus 5. Final endpoint minus initial endpoint. This gives us the change in time interval. So minus 20 over 4 ultimately becomes minus 5. So minus 5 meter per second meter per second is going to be the average velocity for this displacement. Then in the B part, they said find the body's speed and acceleration as in the first 4 questions what we solved. So the body's speed actually equals to the absolute value of the velocity at time t. So what is the absolute value of the velocity? So let's find the velocity first. The velocity v at time t is actually velocity equals to the derivative of the function of the displacement, ds over dt. So what is d over dt, and the s is going to be as 25 over t square, 25 over t square, minus 5 over t, minus 5 over t. Okay, we need to shift the denominators to the numerator position to make it more comfortable doing the derivation. So d over dt. It would be more comfortable if we say it's 25 raised to power t raised to power minus 2 minus 5 into t raised to power minus 1. Now we can do derivation quite easily. So it's going to be 25 into 150, but with the negative sign, minus 50 t raised to power minus 3 minus plus 5 t raised to power minus 2. So minus 50 t raised to power minus 3 plus 5 t raised to power minus 2 is the velocity. Now we have to find the speed or absolute value of the velocity at the two endpoints. So at the first endpoint, the velocity speed at the first endpoint, which is 1, because time interval starts from 1 to 5. So at 1, the speed is going to be equals to, let's substitute t with 1 everywhere. Wherever we see the t, we switch it with 1 raised to power minus 3 plus 5 into t, which is 1 raised to power minus 2 in the in the velocity equation. Okay, so let's switch this into the color green, so making it more common. Okay, so this is going to be minus 5, 1 raised to power, whatever the value, it just comes itself. It's going to be minus 50 raised to power 1 is 1 plus 5, 1 raised to power, we shift it to the denominator position. So here the 3 R2 becomes positive, and ultimately the values becomes as it is. So we are done. So it's minus 50 plus 5, which is minus 45 meter per second is the speed at when t equals to 1, 45. And due to the absolute value afterward, as we are looking for the absolute value, so due to the absolute value, this minus 45 becomes positive, and this is our speed at one of the endpoints. Now speed at the endpoint 5 will be something like this. So minus 50, t is 5 this time, raised to our minus 3 plus 5 into 5 raised to our minus 2. Now I'm going to shift them to the denominator position to make it more easily soluble. So 5 raised to our 3 plus 5 raised to our minus 2 means 5 raised to our 2 in the denominator. Further, minus 50 over 5 raised to our 3 means 5 times 25, 5 times. Okay, one thing, let me use the calculator to save more time here. Okay. 5 over 5 is minus 50 over 5 is 3 plus 5 over 5 square. And this is going to be equals to 1 over 5 meter per second. 1 over 5 meter per second. That's the speed at the other endpoint, minus 1 over 5. Okay, speed and acceleration. Acceleration, just derivation of the velocity, as we have just found that this is our velocities, and we just need to take its derivation, which equals to the acceleration, and then we have to find the acceleration at the endpoints as well. So acceleration equals to rate of change of the velocity, which equals to, let's find the derivation of the function, which is this one. Remember, this is the velocity, so we have to find its derivation. Due to the space, I'm just solving directly. So it's going to be minus plus 53 times 150 t raised to our minus 3 minus 1 is minus 4 plus minus 5 2 times 10 and t raised to our minus 3. This is our acceleration. This is the expression for the acceleration. Now we have to find the endpoints, acceleration the endpoints. So let me make a little space here. Okay. So acceleration at the endpoint 1, because 1 to 5. So acceleration at the endpoint 1 equals to 150 into 1 raised to our minus 4 minus 10 into 1 raised to our minus 3. Okay, so it's like 150 over 1 raised to power 4 minus 10 over 1 raised to power 3. So it doesn't matter whether we have 1 raised to 4 form and anything or not. So this all becomes equals to 150 minus 10 equals to 140 meter per second square. That's the acceleration at one of the endpoint, and acceleration at the final endpoint, which is 5, equals to 150 into 5 raised to power minus 4 minus 10 into 5 raised to power minus 3. Just using calculator here this time. So 150 into 5 raised to power minus 4 minus 10 into 5 raised to power minus 3. Okay, so the answer becomes 0.16 meter per second square. Acceleration at the other endpoint. Question number 6, with the same problem, they said find the acceleration and the velocity. Okay. This is the displacement function. The distance function is s equals 25 over t plus 5. Okay, there's one more question about that, whether it's going to change its direction or not. That's the C part of the question number 5. Question number 5. Okay. So we have to find whether it's going to change direction or not. For this reason, we have to let this, the velocity equals to 0, because if it's changing its direction, it means the velocity, before it actually turns to a different direction, it has to come to the 0. Okay, what is the velocity? Velocity given here is 50 t raised to power minus 3 plus 5 t raised to power minus 2. So it's going to be 50 t raised to power minus 3 plus 5 t raised to power minus 2 x equals to the velocity. Okay, velocity at time t equals to 50 t. So I say, okay, if it equals to 0, then it means 50 over t cube plus 5 over t square equals to 0. What's the common LCM? Common LCM could be t cube. I have to multiply with t here and t here. Okay, the common LCM becomes t cube. So we have 50 plus 5t equals to 0. It's a negative sign? Okay, sorry. So it's going to be minus 50. Acceleration will do the same thing. 50 t raised to minus 3. Yeah, okay. So let's see if it's going to change direction or not. But before that, we need to find the value of the t. So t times 0 becomes 0. And then minus 50 plus 5t equals to 0. Shifting 50 to the opposite side equals to 5t equals to 50. Or t becomes to 50 over 5, which is 10. So at t equals to 10, is it changing direction? Well, so the problem is we are not given the time interval other than 1 to 5, and our t is actually going to be equals to 10. It means body never changes its direction, because it's changing direction at t equals to 10, which is not even in the interval we are discussing. So we say it never changed direction, because the time interval is not even into the consideration which we are in right now. Question number 6, same situations, speed and displacement and average velocity first. So the A part, displacement equals to displacement at the end point, which is 0, minus displacement at the end point, which is minus 4. Okay, so 0. If you put 0, 25 over 0 plus 5 minus 25 over minus 4 plus 5. So let's see what's the answer. Let's make it more room. Okay, so yeah, I think it's all right. Okay, so this is our displacement, so this equals to 25 over 5 minus 25 over 1. We can't do anything except if we make the denominators common, so I'm going to multiply this side by 5 and this side 5 as well. So our common denominator becomes 5 here. 5 common denominator, so 25 minus 125, which equals to minus 100. Okay, so it's going to be minus 100 over 5, which gives us minus 20 meter. So this is the displacement. Now for the average velocity equals to change in the displacement over change in the time interval. Displacement is already given change, which is minus 20. The interval is 0 minus minus 4. 0 minus minus 4, which is minus 20 over 4. So it's going to be equals to minus 5 meter per second. This is the average velocity. Now in the B part, they said find the speed, which we knew that it equals to absolute value of the velocity. So we need to find what is the velocity first. So velocity at time t equals to, which is actually going to be the derivative function, rate of change of the displacement actually. What is the displacement function? 25 over t plus 5. Okay, 25 over t plus 5. So 25 plus t over 5 is going to be, we're going to find this rate of change here. Okay, this is a fraction, and as we didn't just went through the main concept, so we can use the quotient rule here. And how can we do that? Actually, it's very easy with the quotient rule for right now, but later on we will be introduced to the actual concept and the formula and understanding afterwards. Okay, so we just write the denominator as it is, and then we take the scale on the denominator. That's how we're taking the rate of change of displacement with the fraction here. Okay, remember using the quotient rule. So t plus 5 with square, which is denominator, actually the square of the denominator. Then we write our value of the denominator once in the numerator again, t plus 5 there again. And here we take the derivative of 25, which is 0. Then minus. Now we write the numerator as it is, and now this time we take the derivative of t plus 5, which is, of course, for t is going to be 1 and for 25 is 0. So let's simplify it further, which is 0, everything 0, minus 25 up there, t plus 5. Oh, perfect. So this is actually the velocity. Now we have to find the speed at the endpoints. So speed is what? Speed is actually nothing but the derivative function of the velocity. Absolute value. Okay, the absolute value of the velocity. So absolute value of minus 25 if t is let's look at the interval minus 4 and 0. So if t is minus 4, it's going to be minus 4 plus 5 perfect square, which ultimately equals to minus 25 over 1. 1 square is 1 minus 25, which will become 25 due to the absolute value, meter per second. And then speed, which is absolute value of the velocity at the end point 0, equals to, so everything, so t will switch with 0 this time, minus 25 over 0 plus 5 equals to minus 25 over 5 is going to be minus 5 perfect square. So 25. Okay, so 25 over 25, it's going to be minus 25 over 25 is minus 1 with absolute value it will become positive, so 1 plus 1 meter per second. That's the speed at the endpoint. Afterwards they said find the acceleration as well. Acceleration is what? Acceleration is actually the rate of change of velocity. Acceleration is actually equals to the rate of change of velocity. Here the velocity is minus 25 over t plus 5 perfect square. Okay, so again we have to apply the quotient rule because it's a fraction. So as usual, acceleration equals to derivative function, we actually square the denominator, so t plus 5 will become 4 here. Then we write the denominator function as it is once, which is t plus 5 perfect square. Then we take the derivative of the numerator, which is minus 25, and its derivation becomes 0 minus. Then you write the denominator, the numerator as it is, minus 25, into the derivative function of the denominator. So derivative function of the denominator, if this is our denominator, the derivative function will become 2 into t plus 5. 2 minus 1 is 1. So 2 into t plus 5. 2 into t plus 5. Okay. So let's simplify it further. Acceleration equals to t plus 5. This whole become this whole becomes 0. Then minus 5, 25 into 2, which is 50, into t plus 5, and everything divided by t plus 5 raised to power 4. One of the power is to be cancelled with t plus 5, and we are left with 3 here. So the final acceleration's expression is actually 50 over t plus 5 raised to power 3. That's the final expression for our acceleration. Okay, now this side find the acceleration at the endpoints. We have the endpoints at 0 and minus 4, remember. So acceleration when the endpoint is minus 4, so it equals to 50 over minus 4 plus 5 perfect cube equals to, so no matter what you take the power of 1, is still 1, so it's going to be 50 meter per second for the first point. The other endpoint is 0, so a into 0 is actually, a for 0 is 50 over 0 plus 5 perfect cube equals to 50 over 5 times 25, 25, 5, so 125. When you subtract this 25, 2 times 50, 3 times 20, 5 times 25, 5 times 25 is 2 over 5 meter per second. That's the acceleration at the other points. Okay, the last part, the C part, which asks you about whether it's going to change direction or not. So we, as usual, we say if the velocity equals to 0, only then we can say that. Okay, so what's the velocity? The velocity is actually minus 25 over t plus 5 perfect square. Minus 25 over t plus 5 perfect square. So minus 25 over t plus 5 perfect square if it equals to 0. But as we can see that when we times it with 0, it actually becomes minus 25 equals to 0, which is not possible. Minus 25 cannot be equals to 0. So what does it imply? It implies that body never changes direction. And this is the end of our question number 6. With more questions and discussions further, stay tuned for the next video. Bye.